write a factorial method. Now, you may have heard this before in like a probability class or an algebra 2 or college algebra course. Um, this is like a canonical example. So, for instance, 5 factorial, that's what that exclamation point means. That's 5 times 4 times 3 times 2 times 1. And then you stop, and that should be 120 degrees. Now, there is something to observe here. 5 factorial, you'll notice, that's the same thing. 5 factorial, you essentially have 5 multiplied by 4 factorial, because 4 factorial is 4 multiplied by 3 factorial, and so on and so forth, until you break this down completely. So I have the table set here to write this static method called factorial. Notice we'll throw an illegal arg exception. We're not going to take factorials of negative numbers. Okay? So we're going to write out this method. So again, like 20 factorial would be 20 times 19 times 18 times 17, yada, 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 times 3 times 2 times 1. And you multiply all that business together. So one thing to notice, 1 factorial is 1. Also, 0 factorial is defined as 1. So this is known as, it's known as our base case. That's what we call it. Now, you always have to have a base case when you are writing a recursive method. So our base case is if n is less than or equal to 0, really it's just going to stop at 0. We can just return, we'll actually go for 0. If n equals 0, we'll just return 1, because 0 factorial is 1. Okay, so that is our base case. And so we're just going to kind of whittle down any factorial. It's going to get closer, and we're going to have this. We're going to have the recursive case where it's going to break down n factorial into n times n minus 1 factorial. Okay, so if the number is 0, boom, we're just going to return 1. Otherwise, we're just going to return n. We're going to return n multiplied by, we're going to call this function again, we'll call factorial. And now we're going to call factorial on 1 less, so on n minus 1. Okay, so we have our base case when n is 0. Otherwise, we'll return, so we have our recursive case here. We're going to call the factorial method on 1 less. And we'll multiply what we have currently by that factorial call to 1 less. Kind of like how I was saying 5 factorial is 5 times 4 factorial is, which is, and 4 factorial is 4 times 3 factorial, and so on and so forth. So we've got our if statement, and we've got our else statement. Unreachable statement, yeah, we don't want the return n here. Of course, that was, I just had it stubbed out when I was getting this set up here. Okay, so this is really all you need here, team. You need the base case. You always have to have a base case. Otherwise bad and potentially dangerous things can happen in your code. So you need to make sure that you have the base case. Otherwise, the method will just call itself indefinitely. And eventually that's going to lead to a Stack Overflow error. All right, so you don't want that. You'll also notice that we need to be changing the parameters here. Notice how we're winnowing down, we're decreasing n, we're turning it into n minus 1, so we're slowly headed towards our base case. We're making things smaller. You need to have each recursive call get smaller and smaller and or head toward your base case, um, so that so that the recursion actually works. Because again, you don't want that. You don't want like infinite amounts of recursive calls because you'll get that Stack Overflow error. So what's interesting is this is really all you need. This is your first um, recursive method. Now it's recursive because it's calling itself within the method body. So that's what's interesting about it. All right. So if we test this, a bunch of numbers in an array just for fun. Also, great opportunity to use a little bit of printf here. But so then we have our factorials. 1 factorial is 1, 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 120. And oh my goodness, 10 factorial is 362,880. So that's what, if you bundle this in threes, that's 3,628,800. So that's a beautiful thing. Now, if I just want to kind of spice this up a little bit, just for us to understand a little bit better, we'll call it a recursive call. Why doesn't it like this? Recursive call. I just want to print that out. That's in my else. N is an integer. What seems to be the problem here? All right, everybody's happy. So if I run this again, let's check it out, just so we can learn a little bit more here. Let's look at the 120. So first, we were given 5. We decreased it by 1, so we had a recursive call. We needed to know factorial on 4. So we wanted to know 4 factorial. We wanted to know 3 factorial, 2 factorial, 1 factorial. We wanted to know 0 factorial. And finally, that tripped the base case. So then we had 1 times the previous call, 1 times 2 times the previous call, 2 times 3, so on and so forth. We built our way up to get to 120. So it helps to write in, and I'm going to trace like multiple choice questions to kind of show you the like recursive call stack. But it's kind of interesting how you kind of drill down to the base case and then you kind of work your way back up to finally get to your result. So that is your first gentle introduction to recursive methods. Be well.